Good morning, good afternoon, good evening, wherever you are. I am Nick Chase from Mirantis, and I would like to welcome you to today's webinar / mini course, Top Sysadmin Tasks and How You Can Do Them with OpenStack. Before we move on, let me introduce today's presenter / instructor. We have Greg Pavelski. He is one of our instructors here at Mirantis. He teaches several of our courses. So as I was saying, Greg teaches courses on OpenStack, on Kubernetes and Docker, on MCP and SDN. He is an expert in networking and security and all kinds of things. And so he is going to show you how these things should be done, which is good. Greg, if you can let us know what we're going to be talking about today.
Okay, hello everybody. So this is our agenda for this demo. So the goal of this demo is to show how to create a simple web service, a really simple web service on top of OpenStack environment cluster. So we are going to perform following steps, following configuration. So we are going to create an OpenStack environment, user, project. We will see how users are authorized on projects. So in OpenStack terminology, it's called role assignment. So I'm going to show you how to prepare OpenStack environment to be able to do to start doing anything. Then we are going to upload the virtual machine image, which is suitable to run our really simple web service. And then we are going to create this web service using automated way. So we are not going to do it manually, but instead we are going to use a text file. In OpenStack terminology, it's called Orchestration Template or blueprint. So it will be in a programmatic, automated way, not manually. Then we are going to check if this web service works correctly as expected. So we are going to test it. Then, if we want to reach it, if we want to reach that web service from outside of our OpenStack cluster, then we will have to give it a floating IP. So that's another optional step to enable that web service. And then as another optional task, we will see how to modify authorization policies on OpenStack. So as an example, I'm going to modify the policy so only admin role can delete images. And then at the end, we are going to have a Q&A session. So I'm going to try to answer your questions. So let's start the OpenStack configuration. So as I said, the first step is to prepare OpenStack environment correctly. So just let me log into OpenStack. So I'm going to use, during this presentation, I'm going to use DevStack. So DevStack, it's a very simple tool to run OpenStack even on your laptop. So if you are interested later on how to repeat all the steps from this demo, you can also do it on your own on your laptop. So we can give you information later on how to repeat all those steps on your own. Okay, so just let me sign out just to show you how the initial screen looks like. So that's that's interface. It's called Horizon. So that's OpenStack web GUI. So let me log in. Okay, so I logged into OpenStack web GUI called Horizon. So I see several panels here. The most important panel for this part is project panel, because under project panel we are going to configure everything. But there's also admin panel. So admin panel is used for a global administrative tasks for the whole cluster, not for a particular project. And then we have also identity panel. So identity panel is used for managing, managing projects and users. So what project is on OpenStack? So project is a container for all the resources users have access to. So all the resources created on OpenStack, they belong to project, and project typically represent a tenant. So it could be organization, it could be customer, and then a group of users are assigned to projects to be authorized to perform actions. So just to give you an example how to create a new project, we can go to project panel. We can click create projects. So let's call it practice. Then I'm going to create a practice project. You can also specify quotas here. So quotas are this is a upper level of resources given project can consume. So we can basically limit number of resources taken by one organization, by one group here by setting quotas. So let's leave those quotas default. Okay, as you can see, I managed to create a new project. So now I can create a new user. For example, user John. And I have to specify password. And I have to select a primary project of that user. So let's make it practice. Okay, and now I have to specify what kind of role that user will have on that project, because on OpenStack authorization is based on roles. It's not based on usernames. So even if you give if you name user admin, it doesn't mean anything to OpenStack. You have to give that user a role. So I want to make that user admin on that project. So I create user. So now we have user John created on project and assigned on project admin with a role admin, so we can test it if it works. So just let me sign out from admin account and let me log into as John. Okay, so I'm logged as a John, and I'm on project practice. User can actually belong to many projects at the same time. So if you want to switch to another project, you can use that place. Of course, John is only assigned to project practice, so we cannot switch to another project. Then we can see what kind of resources exist on that project. Of course, because I created that project just from scratch, there will be no resources created by default. We don't have any images. We have just some public images which are globally available on our cluster. We don't have any project-specific images, or we don't have any, for example, network or subnets or routers. Everything is empty. So you have to add those resources either manually or with some automation. Okay, it would take too long, or it would be too complex to show you how to add all those resources in this short presentation. That's why I have a project with some resources already pre-created. So let me log out and log into project demo with admin user again. Sorry, admin user and demo project. Okay, so I'm back to admin and project demo. And here we can see, if we go to project resources, we can see networks and routers already pre-created. So we have private network, we have router. We can check our networking topology, network topology here in network topology. Okay, we have some virtual machine created, so we can even delete that virtual machine because we don't need it anymore. Okay, it's being deleted. So let's assume we have our OpenStack environment created. So we have a user, we have a project. That user has a role assigned on that project. The project has quotas. Project has some basic resources you need for you need to create a virtual machine. So, for example, images or networks or routers and so on. So that is the initial step you have to perform to create your environment. So the next step to create our web services will be to create or fetch from somewhere and upload the right image, which will be suitable to run virtual machines for our web services. So let's go back to OpenStack. Okay, so you can create an image by simply clicking on create image. Of course, we have some images here available, but these are public images which are global for the whole cluster. So all the tenants from this OpenStack cluster can use those images. But a better way is not to trust the default images, but use the image you are really sure will be suitable for your services. So in my case, again, to make it faster, I'm not going to prepare image virtual machine image on my own. There are actually many tools to do it, like Packer or some other tools from OpenStack community. I'm not going to use it. I'm just going to download an image which is pre-created by community. So I'm going to use an image from a project called Syros. So just let me show you. So Syros, it's a very small minimal operating system based on Linux. As you can see, Syros image, you have many images here, different types for different architecture, different formats of images. I'm going to use this one. That's a 32-bit architecture for Intel and QCODE2 format. This is suitable for our OpenStack environment. It's very small. It's just 12 12 megabytes. It's not good for production, but it should be suitable for our presentation and for testing. So I'm going to copy link for that image, and now I'm going to create a new image. So I click on create image. So now it asked me to give it a name. So let's name it my Zeros. Description is optional. So all those fields here with the blue asterisk, they are actually mandatory, so I have to fill them in. Then it asked me for image source, so I want to be downloaded directly by OpenStack from URL. So I can just paste this URL I copied from Zeros web page. Then another mandatory field is to select format. So as I said, that is supposed to be Qcode to QEMU emulator image format. So now I'm going to click create image. That should be pretty fast to download it and create it because it's just 12 megabytes. Okay, it's already created and should be available. So let's check the other step. Okay, so we have OpenStack environment created. We have our image uploaded. So now we can focus on web service itself. So in this step, we are going to create our web service stack using an OpenStack orchestration template. So what is a stack in OpenStack terminology? So stack in OpenStack terminology is a group of resources automatically created and managed by a template. And template is a text file which describes all the resources which need to be created. For example, virtual machines, storages, networks, routers, application stacks running on top of those virtual machines. So all those resources created by template working together as a one application is called a stack. So instead of creating those resources manually, one by one, in the right order, you can create a template text file to describe it, and OpenStack will create it automatically. What is also important to understand about OpenStack orchestration, that it's not just a fire and forget. OpenStack orchestration can manage application or resources stacks for the whole lifetime, their lifetime. So if you want to update something or you want to delete it, you don't have to delete all the resources one by one again. You can just delete the whole stack, and everything will be deleted automatically. So this kind of management sometimes is called infrastructure as a code, because you can apply all the principles to manage your infrastructure, all the principles taken from source code management. So you can just use CI/CD pipelines for changes review, for automated testing. That's a beautiful solution for DevOps, because you can apply exactly the same principles you typically apply to manage source code. So in other words, stack is just an instance of resources created from template. Okay, so sorry for this little bit too long introduction, but it's important to understand some basic vocabulary, especially for beginners. So let's see how to do it practically. Okay, so we have a panel for orchestration management here. So if I click on orchestration, I can just see how many stacks we are running right now. Okay, I don't see any stack running on this project, so it's empty. So again, it would take probably too long if I created orchestration template, and if I created web service just from scratch. So I actually pre-created some template and web service to run it, and I just put it on GitHub. So if we go to GitHub and go to my repo, we will see two files. So the first file with the YAML extension is our orchestration template. So this orchestration template has some specific format, and which format we are going to use is defined by hit template version. So this date here is actually not a date I created this template, but it's a language version. It's an orchestration language version we are going to use. So that's mandatory information in template, because hit needs to know how to parse and interpret all the statements. So it's based on this versioning here. Then there is a optional description which explains what this template is supposed to do. So in our case, it's supposed to deploy a simple web service on top of Zero's image. Then we have optional section called parameters. So this section is optional, and it defines all the parameters user will be prompted to provide when executing this template. So what are parameters useful for? They are useful to simply parameterize our template. So instead of encoding all the parameters, hard coding actually all the parameters directly on the resources we want to create, we can just have those parameters provided. So it's just like parameters taken by function to be executed. So the next section is called resources, and resources is of course mandatory section. So without resources section, your template will not do anything. So in our case, we have just one resource on the resources section, and it's called web server, and the type is OS Nova server. So this resource is a virtual machine. So that template will create one virtual machine, and then we have properties of that virtual machine. So we specify image. Okay, we don't hard code which image is going to be used by this virtual machine. User will be just prompted to provide it when they run this template. Then we have flavor. So flavor is hard coded. And then there is one more important piece of configuration. It's called user data format and user data. So user data, it's a script which will be passed to our virtual machine when it's booted to be executed. So what this script here does, it's actually one thing. It downloads from a web server and installs on our virtual machine a web service. Then it makes that web service file executable, and then it executes that web service. So that's a very simple sequence. We download, install our file in the right directory, we make it executable, and then we execute it. Okay, so that's one part of our web service. So let's see that's our orchestration template. And now let's see what our web service is. So this is just a shell script, and as you could see, we will put that shell script on a run level file, on a run level directory. So this script is actually a run command which will be executed by init whenever our virtual machine is booted. So so we have a couple of statements here. Okay, there's function start. That's the only function I provided because we will be just starting that service. We will be not stopping or restarting. So there is start function, and this start function it runs as I already told you. C-ROS operating system. It's a minimal version of Linux, so there is no package management. We cannot install easily Apache or something more sophisticated. So we are going to use Netcat. Netcat is a Linux tool to connect or listen on a particular TCP or UDP port. So in our case, Netcat will listen on port 80, which is a port typically used by web services. And when someone is connected to port 80 and they execute something, then we will just produce output formatted using HTTP 1.0 protocol, and that will give a string, will produce a string welcome to hostname, and hostname will be replaced by a real hostname of our server. So I would say that's a pretty simple orchestration template to run extremely simple web service. Okay, so we have it on GitHub. So now we have to copy those files from GitHub somewhere to a place reachable by our OpenStack cluster. So we covered our orchestration template. We covered what is our web service, and now it's time to run it. So as I said, we need to copy as we don't have actually connectivity from our OpenStack environment, which just runs on top of virtual machine. We don't have connectivity to the internet. I have to copy those files to some place which is reachable from our OpenStack cluster. So I need to do it using a command line. So that's one of very few places a command line is needed for that. Okay. Just let me increase the font a little bit. Okay, I think that should be better. So I'm going to SSH into my OpenStack environment, which is DevStack. This DevStack is all-in-one, so we run all the OpenStack components on one virtual machine. So as I told you, you can run it on your laptop. You just need to have at least 4 gigs of memory, and then you should be able to run it. Okay, and then I'm going to copy our templates and web service file to some directory. I'm going to use git clone command for that. Okay, so now we got this OS webinar directory created. If we go to that directory, we will see that we have files copied. We can also access it through browser because that directory is also exposed by web server. So okay. So we have those files also exposed on web server, which will be reachable from which runs actually locally on our OpenStack environment. Of course, this address visible here, this is a public address of our virtual machine we run OpenStack on. So if we want to access it internally from OpenStack, we have to use some local address. So for example, IP -OA. We can use, for example, one of those addresses here. For example, this one to access it locally. Okay, so let's go back to orchestration. So now I'm going to start our stack. So you have an option to provide a file, direct input, so you can copy paste it here, or you can also provide an URL, as we have our orchestration template exposed on a locally running web server. I can just provide URL, but I have to use this local IP address, so it will be HTTP. Actually, I have it here in my memory. And then it also asks for environment source. So what is environment source? It's the input file which will fill all the parameters which are needed by this template. So you can just parameterize your template also automatically by providing this environment source file. In our case, I don't want to use it. I just want to be prompted to provide those parameters manually. So I click next. And now it asks me to give a stack name. So yeah, let's call it GP. Then it asked me for password for user admin because it needed OpenStack password to act as a user admin, to orchestrate all the resources as user admin on the right project. So I have to provide it with password. And now it asked me for image name. So if you remember our orchestration template, we specified under parameter section, we defined that image name parameter. So we have to provide this image name. and then that name will be used as a property for our virtual machine. So here we have a reference, so we could just replace that reference with a hard-coded name of image, but I just want to show you how to parameterize templates as well. So, for example, flavor is defined statically. Okay, so as far as I remember, I just name it my zeros. The image I created was named my zero, so now I can try to launch it. Okay, so stack is create in progress. It's getting created. It shouldn't take too long, but it's still. Okay, we can check if we see our virtual machine. Yeah, we can see create complete. So now I would expect to have that virtual machine created and to be visible under instances. So instances are virtual machines. Yeah. So let's see if that virtual machine is already booted. So we can go to console and see. It's still booting because there is no terminal prompt available yet. Yeah. So it looks like it's successfully booted. So we can log into console, zeros, caps win. As you can see, that operating system is suitable just for testing because it even gives you its password in its banner. Okay, so now we can see if we run. Netcat. It's not running. Okay, we need some troubleshooting here. Why it's not running? Why it's not running? Okay. So let's check our. Yeah. The problem is here. We just have it exposed on. Exposed on different directory. So we have to modify our template to fetch our web service script from the right directory. So what I can do now is to I can simply delete our our stack. So no, I just don't want to do it manually. I just want to use orchestration for that. So I'm going to stacks and I'm going to remove the whole stack. Okay, and in the meantime, I can modify our template to use the correct path. Yeah. Now it should use the right path. Okay, so we can try to recreate it once again. Stuck URL HTTP. Okay. Next. GP. Password. My zeros. Launch. Yeah, complete. Let's check the compute and instances. Okay, it's still creating. Booting. Okay, so what will be the next step? So once we got our stack successfully created, I hope so, we have to test it. So we have to check if our application is up and running and it's reachable. So the first method to check if it is running is just go to virtual machine itself and test it. If it is, and check it if it is running, and then test it using some web browser or some web testing tool like CURL or wget or something. Okay, so we have zeros, cam, swing, smile. Yeah, so this time it got installed and started properly, so we can test it. So we can actually use Horizon for that. So we can go to instances and check what is the IP address of our virtual machine, and we should have that web service reachable on that address. So we can use, for example, CURL, HTTP. It does not work. So the first reason it does not work is actually that it's not supposed to be accessible outside of our cluster without so-called floating IP. So if we want our application to be reachable from the internet, so in this case it's just outside of OpenStack cluster, not the real internet, we have to use floating IP. And floating IP is an IP address which is routable outside of OpenStack environment. So if you want your application to be reachable from the internet, it must be reachable on the internet. So we have to allocate and associate floating IP. So we can do it using using Horizon, so we can go to Access and Security. Floating IPs, allocate floating IP. Of course, all those steps, they could be also performed by template. They could be programmed to do it in template. It is just to give you an idea why automation is considered to be so useful, because there are so many steps to be performed, even to create a very simple service like this. That's why I'm doing this manually. Okay, so I'm allocating floating IP, and now I'm going to associate it with our virtual machine. Yeah, so this is our virtual machine. I associate it with that virtual machine. So from this moment, it should be reachable on this IP address. But there's one more step we have to perform, because by default, any incoming traffic to our virtual machine is blocked, so we have to add a rule to enable HTTP traffic. Again, you could also do it with the orchestration template. Okay, so now we have floating IP, we have HTTP enabled, so we can, but now we cannot use this fixed IP, we have to use this floating IP. Yeah. So our web service is up and running. So as the last step in this presentation, we can modify the policy. So
Greg, we have 8 minutes left. So
okay, so that was an optional step actually. So we can move to Q&A session.
Okay, so before we go to the Q&A, if you would go back to the slides for just a minute. I just want to go to the bonus slides that I promised everybody at the beginning. So we'll move forward one more time. There we go. So we have several courses that you can go ahead and take a look at training.mirantis.com, including, I believe, 2 Kubernetes classes. There's OpenStack classes. If you're here, presumably you're interested in OpenStack classes, but also given the preponderance of people who are interested in Kubernetes networking, definitely there are classes for you there as well. For attending this webinar and sticking it out to the end, you can get 20% off by using the code MiraOSWeb when you register. So go ahead and do that. You can use that for any of the classes, not just for the OpenStack class or the Kubernetes class. So let's just kind of jump into the Q&A real quick here. What's the level for the OpenStack bootcamp? Let me answer a couple of these while you kind of look through the other questions that we have here. So the OS 200 class, you just need to have some Linux experience and an understanding of general fundamentals of networking. How much is lab-based? They're about 50-50 theory and hands-on rather. The OS 200 class is the deployment class. It's more lab heavy. It's about 60-40. Other logistics questions. Let's see. What's the difference between on-demand and virtual training? Virtual training is a live instructor-led class. It's just like being there in person, only you don't have to be there in person. The online on-demand is, as it says, on-demand, self-paced, work at your own schedule. do you have any courses that prepare you for the Certified OpenStack Administrator exam? Yeah, so OpenStack Bootcamp 1, the OS 100 class is a good preparation for that. By the way, if you take the self-paced OS 100 class, you get one free COA exam attempt. So if you pass it, you don't have to pay for it. The exam, that is. Let's see, hardware prerequisites for the classes. You have to have a laptop with SSH and a web browser. And if you don't have that, I don't know what you're doing listening to this in the first place. Okay, so let's see, other questions. Shouldn't you also be able to log into the project admin as the project user?
It depends. It depends on your configuration. Depends on to which project user is assigned to, because user can be assigned to one or many projects at the same time. So you can model your organization requirements. For example, you can have user John, who is just a regular member on project marketing, but is admin user on project finance. So it depends on your configuration.
Great. What user privilege do you need to be able to create a network? Admin, or can a user member also create a new network?
Again, it's configurable. It's configurable, and it depends on your policy. So this is what I just wanted to show you actually in this step. So if we go to, maybe it's better like that. If we go to a file, etc neutron policy.json, you have statements: create subnet, create network, and so on, create subnet pool. So you have all the possible actions you can perform on Neutron, which is a component for networking. And here you can configure what kind of role your user should have, what kind of authorization you expect to be performed to be able to perform any action. By default on OpenStack, users can create their own private networks on their project, but they cannot create networks on other projects, or they cannot create so-called provider networks, which are mapped to particular physical resources on OpenStack cluster. So yeah, so that's the answer basically. It's configurable, and by default you can create only private networks on your project if you are not a cluster admin.
Let us move right along. We have time for one more question really quickly. How can I run OpenStack on my machine?
As I said, you can run it exactly in the way I'm running OpenStack right now. It's called DevStack, and DevStack is just a bunch of shell scripts which download OpenStack software from GitHub and install, configure, and run it on your machine. It's recommended to run it on a virtual machine. So you could run it on top of VirtualBox, VMware Player, whatever on your laptop. We can actually provide you with some instructions as a follow-up of this session.
I think that would be terrific. Let's plan on doing that. Okay, so that brings us to the end of our time. I want to thank everybody. I want to thank you all for being here and spending your time with us. We love doing these mini courses. Let us know what we can do to serve you better. Also, I want to thank our presenter, Greg, and also our back-end support, as always, Michelle Yukura. Thank you so much. We could not do it without you. And we will see you all next time. Thank you all very much.
Thank you very much.